Hello and welcome. Thanks for joining us for our presentation, Big Data Projects in the Cloud, Choosing the Right Way to Get Started. Before we begin, I'd like to cover a few housekeeping items. Each attendee is in listen-only mode for the duration of our presentation. We will be engaging with the audience through a question and answer session at the end of today's webinar, and we encourage you all to submit any questions you might have at any time during today's presentation through the chat feature you see in the lower left corner of the ReadyTalk platform. We'll be taking as many questions as possible, and if we don't address your question directly, we'll be sure to follow up with you individually. At the end of our presentation, each presenter's contact details will be available. Today's presentation is being recorded and will be available following the presentation. Snowflake will be sending you the recording by week's end. Now, I'd like to welcome today's presenters. Brian Hopkins, today's keynote presenter, is a principal analyst with Forrester Research. Brian covers systems of insight, big data, data management, and analytics technology architecture and strategy. Michael Ruiz, Solutions Architect from Amazon Web Services, and John Bach, VP Marketing and Products from Snowflake Computing. Gentlemen, welcome, and let's get started. I'll pass the presentation over to our guest speaker, Brian Hopkins from Forrester. Brian, please take it away.
Thank you very much, and welcome. So my name is Brian Hopkins from Forrester Research. And our job at Forrester is really to do two things: challenge your thinking and help you with that new thinking lead change in your organization. So I'm going to set the stage for this webinar for about the next 15, 20 minutes to challenge some of your thinking around some ideas that are probably pretty firmly set in the way you think about things. So let's talk about a new way that we see leaders thinking about things, and then my partners in the webinar will come along behind me and talk about some ways that folks are actually implementing some of these ideas. So the first thing I want to really talk about is what our data says about this idea of data-driven, which seems to be a well-accepted tagline or mantra that a lot of organizations, both on the buyer and the vendor side, are buying into, this idea that we should use data to drive our organizations. And in fact, when we look at our surveys, that's exactly what the expectations around big data are. So for instance, 2/3 of firms will be using big data analytics to help optimize their digital experiences. Over half of firms we think will have Hadoop in some form or fashion by the end of 2016, and 4 in 10 firms in 2015 are spending more than $10 million a year on data and analytics. So clearly it's very important to firms, and that should come as no surprise. But here's the problem. The problem with that is all the discussion about data doesn't guarantee what your business really cares about, and that is action. So let me give you some more data points, right? In a survey of enterprise architects and technology strategists, about 3 in 4 firms said they aspire to help their firms become data-driven, right? So these are technologists, strategists, just like yourself. And so the idea is clearly in their heads that they want to help their firm become data-driven. On the other hand, we asked the same firms how well you're connecting the outcomes of analytics or the results of analytics to business outcomes and action. And frankly, a much smaller percentage said they're good at that. And so the problem is, when you think about those things, it's the thing on the right, the action that business people really want. And data is simply a means to that action, and there's really a big gap between data and action. So what we want to do is begin to set the context for you about what it's going to really take to close that gap. And the first thing I think it means in closing the gap is changing the language you use. The problem with the data-driven language is that discussions about data tend to devolve very quickly into data problems and technologies to manage data, instead of starting talking about the outcomes that you're really trying to achieve and working backwards into the solutions that you actually need to achieve those outcomes, right? So what I'm going to suggest is from a piece of research that I and a partner, Ted Shadler, have been working on now for about 18 months. This is the first report in a series that focuses on the use of the term insight as the bridge between data, the right data, and those effective actions that really drive the business results that will get business people on board with what's possible and what you need to do. So there's really three things that connect data and action, and we call this a system of insight. And we have a whole research series around this that I'm not going to have time to go into, but essentially a system of insight are the practices and technologies that let businesses systematically harness available data, find and test insights, and deploy those insights into processes and applications that drive those processes to make you insights driven. Right, and I'll give you, perhaps we'll talk about some examples here as we go through the webinar, but there's really three pieces to this. So first off, systems of insight are driven by teams, right? And they, as they mature, use a common set of components to derive those insights and deliver those insights to software that we call a digital insights architecture. And finally, they're connecting the data and the actions in what we call an insights to execution process or operating model. And it's really not about all available data, because you're never going to be able to capture all available data in one place, but rather it's about tapping that available data, finding the right data sets to create new knowledge about specific points in a decision, i.e. an insight, and then deliver that insight to a software system that changes somebody's decision and therefore impacts a metric or an outcome that business people really care about, right? So when we think about this systematic way, we see examples of different companies that are actually beginning, and it's just at the beginning of thinking about data and analytics in this way and really changing the way that they do business. So the firms that are really succeeding in this have a significant percentage of their budget and their staff that are working on the data to insights or the insights to execution piece, or finding insights with advanced analytics and data science and delivering those insights in agile development and continuous delivery processes through software becomes not a means, but it becomes the way that their business works. And because of that, they're able to deliver experiences and products and engagements that their competition can't. So when you think about a strategy to do this, one of the things I like to say about strategy is that it's just as important to talk about what you're not going to do as what you are. And the problem I see with data and analytics strategies when I work with technology professionals is that quite often those strategies are about being all things to all people. Anybody who needs our data is going to have it in the time that they need it to do whatever they want to with it, is essentially, in a nutshell, what most data strategies I see say. And they're 30, 40, 50, 100-page documents that nobody ever reads and no action is ever taken on. So what I want to do here is suggest that this systems of insight idea and the way that you create these systems of insight needs to be focused somewhere, and we think the most important place to focus them right now is on insights that drive engagements with people, specifically your customers, and secondarily your employees that engage with those customers. Right now we see the biggest energy at a business level around creating new revenue or creating and growing revenue and creating digital customer experiences as a way to drive that revenue, and thirdly, doing it in a way that's both flexible and low cost. So if you can hit those three things, you're hitting on what businesses tell us are the most important priorities today, right? So that's really important when you think about your strategy. Focus these systems of insight on developing and deploying into software ways to touch and engage with customers and employees, right? That's the most important strategic thing. So I want to kind of bridge from that discussion now into some specific technology ideas. And one of those ideas is the use of cloud for doing this. So for example, this is from a survey we ran in 2012 and 2014. We also ran it in 2015, but it's a similar results. But this is really interesting because we ask about business intelligence, which includes data and analytics combined in the cloud, and what our firm's plans to adopt it. And the thing that we saw was a dramatic shift from in 2012, no plans, right, to having a lot of plans to and willingness to shift these data and analytics and insight systems into the cloud, right? And so your business is reflecting that today, the realization that in order to achieve the kind of customer engaging experiences that you want to have, using these, and I'm using air quotes, big data sets and connected Internet of Everything type of applications, you need the ability to not make large capital expenditures, have a lot of flexibility, and experiment a lot, and the cloud is ideal for that. And we're seeing a growing recognition. That's no longer an argument. And the question about what to do with security and compliance and all, and service levels and how to be indemnified against losses, those are now being viewed as problems that must be solved and not showstoppers, right? So let's drill a bit deeper into that for a minute and get down to the heart of what I'm talking about here. So what we're seeing here is cloud providers or companies that are developing infrastructures in the cloud to enable them to develop systems of insight that engage. They're doing so in kind of with a different architecture. And so this is very much an emerging what we call on-demand analytic architecture. And essentially, we're seeing things like Hadoop and different data storage mechanisms evolve and be enabled in the cloud or grow natively in the cloud. And through a set of middleware that handles things like metadata management, data indexing, data discovery, data transformation, resource management, standing up clusters of analytics capability, these middleware capabilities are then separating out the place that you store the data, like a scale-out NAS or HDFS or a cloud object store, from the analytic workloads that turn the data into insight, from whether you're doing simple SQL to some kind of a parallel NoSQL database to some machine learning algorithms to search and knowledge discovery. And these are all connected via a high-performance network on-premise or in the cloud through, again, the same high-performance networking technology, but then connecting between different locations for where you want to store your data, right? So this is really decoupling the storage from the analytics in the same way that we just decouple storage from applications in previous versions of virtualization, right? So I want to end here and actually give you an example to kind of reinforce some of this stuff. So this example is from a startup in Silicon Valley. They're called Stitch Fix. And what Stitch Fix does is they can sell clothing to people who don't like to shop, which none of their competitions do. So the competition, you need to go in the store, you need to go online, you need to choose and buy something. Well, they do it quite differently. See, what they do is they ship you a box, and this box has things that they think you're going to like in it. And if you don't like the things, you leave them in the box and send the box back. No cost to you. You keep only the things you want. So what that really means is they have to be really good at understanding what their customers want and using predictive analytics to provide advice to fashion consultants who then load the boxes and send those boxes to customers. And what they do is when the fashion consultants choose to put different clothes in the box based on the knowledge of a particular customer, they ask their chief algorithms officer and the data scientists that work for this gentleman ask, why did you do what you do? And they incorporate that in the new iterations of their models. And then they begin a controlled experimentation where they sometimes do the wrong thing, ship the wrong piece of clothing to somebody to learn things about who likes what. And then they also bake that into their models. As a result, they can deliver a customer experience, right, that their competitors can't. And what they said is once they learned how to do this, this way of doing business permeated their entire business, from recommending on the front end to managing pricing and inventory on the back end. As a result, they carry half the inventory carrying costs of other online retailers, which significantly adds to their profitability. And what's really interesting is they carry about 40% of their staff are data and analytics and insights professionals, because their entire business model is built around this. And that's what we really think it takes to be an insight-driven business. And we think that this way of doing business and the architecture is going to migrate from small Silicon Valley startups up into more enterprise companies, because you're simply going to need this to stay competitive. So really quickly, I want to talk to you about the architecture they built this on, right? So the first thing that they do is they source all their data from their production applications through a logging data and a batch ETL pipeline to move all the data back into Amazon S3. Once the data is in Amazon S3, they move parts of the data to Redshift for analytics and reporting. They're also able to use an open source tool called Genie to stand up Yarn Spark clusters on demand to do data exploration, discovery, data science, and predictive modeling, deploy those models back into their online algorithms via REST APIs, right? And then those things are called by the production applications, which then capture the data, and around the system of insight they go, right? So they do big data. This is very much a big data architecture, but they don't talk about big data. What they really talk about is the results they're able to achieve as a business because they are doing business. They're doing the data and analytics and insight this way in the cloud, right? So that's one example that I hope reinforces some of the things that we've talked about here. So I want to give you a second example that's more relevant to our host today, one of our hosts today, Snowflake Computing, and this is from International Game Tech. They have an online interactive casino called Double Down, and their problem is this interactive online casino has been around for a while and been around longer than some of these emerging technologies and the ability to support them in the cloud have allowed. So they had a problem, and the problem is they really weren't optimizing their play. So they weren't able to convert players who were playing online for free to players who actually paid for the experience, right? And they weren't able to change their online gaming environment to meet growing digital expectations of their customers. And they realized they needed some data science capability to do this. So the solution was they had to overhaul their entire data architecture for more legacy ETL and on-prem SQL-based data warehouses so they could capture, integrate, and examine real-time data as players played the games, right? Bring in third-party data and really ask themselves, how do I optimize this experience, both to meet digital expectations and also convert those experiences into revenue, which is what they're all about. And as a result, and I'm going to go into their architecture in a minute, and then Snowflake will be on later, and they can actually answer some questions at the end about some of the specific details. But as a result, they were actually able to detect and improve the game design and issue updates in real time and identify customers who had the potential to be profitable and focus their efforts at converting and revenue on the customers with the highest potential to be profitable, right? The way that they did that was kind of similar to the way Stitch Fix did it, except they made some different technology choices. So again, they were using Amazon S3, but here they chose to use Amazon's Kinesis technology as the stream ingestion to populate Amazon S3. And then instead of using Redshift, they chose to use Snowflake. And we're going to talk later in the webinar about what the Snowflake technology is, and you can examine how Snowflake and Redshift kind of work, what they do. But at the end of the day, they used the Snowflake data and analytics tool as a transformation environment that provided standard SQL capability that they could access directly as a virtual data mart, or that they could use that to actually load physical data marts into technologies that they decided to leave in place to feed self-service BI tools like Tableau or through Node.js to create custom dashboards that provided insights to the products, marketing, engineering, and folks involved in creating revenue streams. Their analytics customers or their insights customers as it were, right? So you don't necessarily see the sophistication here with the feedback loop and delivering insights directly to the customers, which is more what Stitch Fix was doing, but you start to see these cloud-based analytics and insights architectures and how they enable more real-time engagement and enable this systems of insight idea, right? So one of the major things that decisions that they faced is, how much of the existing infrastructure do we leverage? Where do we leave a MySQL database in place by using a cloud-based virtual data mart? How do we balance the options around standardized SQL or kind of what we call new SQL, Hive-type query languages that aren't quite SQL versus more standardized SQL? That was a big driver. And then another thing is, how do we capture data in real time? That's stream data ingestion, so we can access that data as quickly as possible and make decisions on it, right? And the lessons they learned, not specifically, executives needed some convincing, so they had to spend some time proving out their ideas. They chose a technology that gave them more standardized SQL because they thought it was a better fit for their existing workforce. And they actually found that Kinesis, the Amazon technology for stream ingestion, and Snowflake integrated well together. And as a result of this, they have many more use cases that they're working on right now. So 3 things I want to leave you with is final thoughts, and then I'm going to transition over to our Amazon Web Services Solution Architect, John Bach, who's going to tell you more about the Amazon pieces that fit into this and the other kind of architectures they're seeing. So first off, being digital and competing in a digital world, which Stitch Fix and Double Down are definitely digital, but we see every enterprise really needing to get into this space and to be just as competitive in the digital space as these digital natives. And that's number one. You almost have to have cloud as a very large component, if not the component, for your infrastructure. You need the agility, you need the reduced CapEx, you need the on-demand capability, right? The second thing you need to think about here is that elasticity really has 2 dimensions. You need to think about how you elastically scale out the data that you capture, because you're going to continuously be capturing more data if you do this successfully. But the second elastic dimension you need is for your analytics, because you're going to need to scale in and scale out your analytics to realize the idea that there's going to be a lot of dead ends, and sometimes you're going to need to do one thing, realize that doesn't work, shut an analytic workload down, and spin another one up. So that's an in and out kind of elasticity. So there's multiple dimensions of elasticity that you need. It's not just about scale out. And the last thing I want to leave you with, and the thing that you saw here, is this notion of software-defined, right? Software-defined servers, software-defined storage, software-defined networks. We can really start to apply that idea to software-defined analytic workloads. So the thing that the cloud and some of these technologies are allowing us to do is to not have to have physical data marts anymore, but replace some of our data marts or some of our analytic workloads like a Spark cluster with a virtual capability in the cloud that can be inflated and deflated as it's needed, and you only pay for it when you use it. Those are really interesting ideas to think about and kind of illustrated with the architecture that are being used as the platforms that drive these companies that are really building systems of insight. Right, so that's the context and how I want you to think about the next 2 presenters we have, because they're going to talk in detail about some of the pieces parts. And so with that, I'd like to turn it over. I'll say thank you very much, by the way. If you are on Twitter and you want to follow me at practicingea.com, you can keep up with me all the time there. I'm tweeting all the time. And next, I'd like to turn it over to my colleague from Amazon Web Services, Mike Ruiz, who is a solution architect there, and he's going to tell you about Amazon's capabilities in the cloud. So Mike?
All right, thanks, Brian. So as mentioned, my name is Mike Ruiz. I'm a solutions architect with Amazon Web Services. I work with the partner teams, working with partners and customers building cool solutions on the Amazon Web Services platform. Today I'm just going to talk briefly about the platform and about its applicability to big data analytics. So why would you use AWS for big data? I'd like to talk about 6 key factors that differentiate AWS for these workloads: experience, the service breadth and depth, pace of innovation, the global footprint of AWS, our pricing philosophy. You talked a little bit about CapEx versus OpEx, and the partner ecosystem. I believe all of these factors are essential to support big data and analytics, and they're key to helping customers drive business value from their data. So let's talk about experience for a bit. I'm sure everyone listening is keenly aware that big data analytics is often complex, long-running, many moving parts. And the results of the analytics, reporting, BI dashboards that we saw a little bit of, or even a loop back into the production application, these can be in the production workflow, and they're very visible at the highest levels of the organization. Restarting a workflow due to a failed component of infrastructure is painful, frequently in the middle of the night, and can often be manual. And can in fact mean restarting the analytics workflow at the very beginning. So it's critical that you have a reliable infrastructure sitting underneath your data analytics. So at Amazon, our engineers are driven to remove any and all causes of failure in the environment. Our goal is to make our operational performance indistinguishable from perfect. So the dedication there and the focus on those factors have allowed us to offer service SLAs with between 99.9% and 100% availability in different configurations. With a key component to a big data analytics workflow, our object store Amazon S3, designed for, it's a lot of nines, it's 11 nines of durability for that particular service. Additionally, we're committed to 100% transparency for the operational health of the entire global infrastructure and offer an AWS Service Health Dashboard for 24/7 visibility in real time, as well as 24/7 service organization supporting the platform. Another component of experience that comes with the experience of AWS is cloud security. So AWS provides the same or familiar approaches to security that companies have been using for decades, along with the increased columns of visibility. We have better visibility in the cloud, control, and auditability. So in the pillar of visibility, the AWS console and AWS APIs provide immediate visibility to your entire infrastructure. All of the EC2 instances running compute workloads, all of the storage, storing your critical data, all of the managed services we offer, the software-defined networking that connects all of these services together or connect these services with your on-prem environment, the security architecture and the security design sitting on top of that. This is all made visible through the console, through the APIs, and through services like config. Additionally, we offer full auditing of all of the access and all of the use of the AWS APIs through a service called AWS CloudTrail. It allows for extremely granular insight into how AWS resources are being accessed and changed. You can alert on that if you're interested in particular accesses or API use. And CloudTrail offers a complete audit log of all access to the AWS API in every region, and you can consolidate all of that information into a single S3 bucket. Another pillar is control. So we take the geographic location of customer data extremely seriously. When you create an EC2 instance or an S3 bucket and place your data and start a data analytics workflow on AWS, you must specify where that will physically reside, what region that's going to occur. And once created, only you can move it. AWS will never change the geographic location of data on behalf of a customer. In addition, AWS offers end-to-end encryption, so a variety of different options, native options for encryption at rest and encryption in flight. So as data moves through the system or between your on-premise data center or on-premise analytics or data sources to Amazon, that data is protected with encryption. It's encrypted when it's stored on Amazon. And additionally, we have a lot of options to enable client-side encryption. So if you want to encrypt it even before moving it through the encrypted pipelines, you can do that as well. You can also bring your own encryption. So if you have an existing security model that you're comfortable with, you can implement that on AWS. So enhanced visibility, enhanced control make it a very auditable platform. And we're able to offer the customers the ability to run HIPAA-compliant workloads, PCI-compliant workloads, comply with DIACAP or FISMA requirements. So different regulatory regimes, it's possible to build applications on top of AWS that are in compliance with those. All of these together allow customers like Tom Soderstrom, a CTO at NASA Jet Propulsion Laboratory, to say things like, based on our experience, I believe that we can be even more secure in the AWS cloud than we can in our own data centers. So for big data, we're often focused on infrastructure and core services, but it's important to recognize that Amazon provides a host of services beyond these core features. So beyond the availability of compute resources and services in different geographic regions, comprised of multiple availability zones for high availability applications, along with 53 points of presence for ingress and egress of data to feed and to consume from your data analytics workflows. AWS offers core services in the area of compute. So our compute core service offering is EC2, where we offer dozens of different instance types with different configurations of memory and storage access, networking access, and bandwidth, as well as different numbers of cores. In addition to that, we offer autoscaling and load balance features within the compute infrastructure. We offer comprehensive storage offerings. So I mentioned S3, which is a distributed object store. We offer block storage offerings that are network attached and have different performance characteristics and sizes available to you, and archival options. Amazon Glacier is a key archival component. In addition, we offer fully managed relational database engines, engines that you're familiar with, Oracle, Microsoft SQL, MySQL are all available as fully managed services on the platform, along with NoSQL options, Redis, Memcached, and Elasticache as a managed caching service. Then finally, and importantly for big data workloads, we offer a variety of networking services. So There's absolutely no need taking advantages of technologies like Amazon VPC or virtual private cloud. There's no need to expose your data to the internet, to the wider internet. You can connect, you can build a constellation of resources in Amazon that talk to each other and no one else. They're completely private. And you can connect that private resource back to your on-prem data center using technologies like Amazon or AWS Direct Connect, which allows you to provision circuits to directly connect to Amazon and consume these resources privately. Of course, you can expose them if you wish. On top of that, fully managed identity management solutions, access control, and auditing, along with key management storage options. To add even more value to your big data analytics workflow, we offer fully managed Hadoop solutions, data pipelines for moving data through various services, either your own services or Amazon managed services, workflow options, transcoding options, container management. If you'd like to explore, containers for doing big data transformation, you can do that as well. On top of that, enterprise applications, virtual desktops for presentation of the data and sharing a collaboration of the data as a result of these workflows. And then finally, comprehensive business and technical support. So 24/7 support organization, professional services organization available to help you build solutions on the platform. Pretty big partner ecosystem. Again, lots of folks available to help you build solutions on AWS. Solutions architects, account management, security pricing reports. Lots of different options for business and technical support. Another key thing we'd like to talk about is the rapid pace of innovation of the AWS platform. So AWS was launched in 2006 with one service, Amazon S3, and since then we've been continually innovating and frequently introducing new products and services to meet customer challenges. Specifically, we produced a lot of services to meet big data customer challenges. So there's a lot of data on this chart. I won't go through it all. You can see that we've added more and more services every year. Of interest possibly are the new instance type we announced for EC2, the X1 instance type, which will offer up to 2 terabytes of memory and more than 100 vCPUs in a single instance. I know some big data or data analytics problems that could be contained or actioned on by that single instance, and you can create, of course, a constellation of on-demand X1 instance types. We also announced Amazon Kinesis Firehose. We talked a little bit about Kinesis. Kinesis Firehose is a wider offering to handle gigabytes of data streaming from hundreds of thousands of data sources simultaneously with absolutely no management on your port to manage the data throughput or the size of the stream. And then finally, a very interesting product for big data and data analytics, and Amazon Snowball. It's a petabyte scale data transport solution that uses secure appliances, so a physical appliance, to transfer large amounts of data into and out of AWS, and it's priced at $200 a job. So you're going to go to the console, click a button. Amazon will mail you or ship you an appliance that you're going to plug into your infrastructure. Data will be encrypted and placed on the appliance and shipped back to AWS for rapid ingestion of large data. And you can reverse the streams. If you need to take data out of AWS for any reason, you can use Snowball for that use case as well. So all 3 of these services announced just a couple weeks ago at reInvent. In the meantime, we've announced 12 other, actually it's more than 12. I wrote this a week ago. So it's 15 additional services since reInvent, including improvements to Amazon SQS, which is a message queue. Now we can move messages of 2 gigabytes of size around. So again, enabling big data workflows within the AWS infrastructure. Let's talk briefly about the global footprint. So it says here Amazon operates 11 regions with 30 availability zones within those regions and 53 edge locations. Additionally, I'm excited to announce that just yesterday we were talking about the availability of a South Korean availability zone in early 2016. And we previously announced that we will be opening an additional North America region as well as a region in India in 2016 as well. So that'll bring the total up to 14 regions with even more availability zones within those regions to drive big data use cases. So regions are important. Data regionalization is important, not only for data sovereignty issues, but again, low latency access to data. And that's where the edge locations and the availability of regions that are close to your data sources are really important. Talk briefly about the pricing philosophy. So I mentioned trading CapEx for OpEx. So as your data analytics workloads scale, you can scale that with a variable expense. So you don't need to in place a large capital infrastructure to solve those data analytics workflows. This also allows you to experiment, to rapidly iterate, and to bring new types of workflows online and offline, as you wish, to unlock that value in that data. So Amazon is also operating at pretty large scale. I think you saw the slide previously. We'll be in 14 regions in 2016. Those scales allow us to offer really competitive pricing, and in fact, we've had 50 proactive price reductions since 2006, since we launched the service. We also offer a variety of pricing models to support a variety of different workloads. So for your fixed workloads, you can reserve instances over some period of time and receive a discount on that infrastructure. And of course, there's always on-demand resources available that you can consume and give back as your workload varies. And then a spot marketplace where you can make a bid on compute resources. And then finally, tiered pricing exists so that as you grow bigger and bring more and more data and more workloads to the Amazon platform, you're going to move through different tiers, and your pricing will go down as your volume goes up. And lastly, let's talk about the expansive partner ecosystem. So AWS has the largest ecosystem in the cloud by far, and it continues to grow at a rapid clip. So we have thousands of technology and consulting partners on the platform, 46 global premier consulting partners to help you build solutions on the platform. We organized competencies within that partner community. So we have a big data competency, a landing page where you can go and find partners that are especially good and especially well suited building big data solutions. And we have 11 others, including security and storage, which could be interesting to you. We also offer AWS Marketplace. It's 2,300 products plus in 35 different categories available for one-click deployment. So these can be complicated projects, Cisco products, Cisco software devices, Red Hat installations, MongoDB, all available through a single click. Lots of uptake of that service. We've ran 143 million hours of compute software through the marketplace last month. So that was a pretty quick sprint through a pretty complicated and expansive architecture. To invite you to go to our Big Data landing page at aws.amazon.com/bigdata to look at architecture and sample deployments. Go to our architecture page. And we also have a lot of recorded content in the form of webinars and blog content, pretty interesting, big data focused blogs as well. So with that, I'm going to hand it over to John at Snowflake. Thank you very much.
All right, thank you very much, Mike. So what I want to do now is turn over and talk a little bit about the Snowflake solution and how it fits together with some of the ideas that Brian talked about earlier, as well as the technology and the services that Amazon provides that Mike just talked about. And my starting point is really, what people are often trying to achieve with these data analytics or these big data projects. And it's pretty commonly, it boils down to they're trying to bring together more data to be able to access and analyze that in new ways. They're trying to get access to that data to more people. And they're trying to reduce the cost and complexity of doing that. Pretty straightforward. But as Brian kind of hinted at, I've also seen all kinds of other anecdotes, the actual success rate of these projects is quite low. And a lot of them are still an ongoing effort that's taking much longer than expected. And some of the reasons for that really come down to the technology. One part of that is the fact that the data that people are looking at analyzing today is much more diverse than it used to be. It used to be that most of the data that people were analyzing came from systems that they controlled that ran in their data center, their transactional system, their ERP system, things like that. But increasingly now, people are looking at data that they don't necessarily control, and it comes in a lot of different forms and formats. And that's something that the traditional systems weren't really built to handle. At the same time as they try to figure out what the data infrastructure that they need is to handle that, they end up finding that they're having to manage and deploy and pay for a wide variety of different systems for special purposes. So the core EDW still has a strong role to play in that. But at the same time, people are now investigating systems like Brian mentioned Hadoop, and there's other NoSQL databases that people are looking at. And then on top of that, there's all these different types of data marts, whether they're data marts to offload the EDW or data marts to provide faster processing for data that was landed in Hadoop. And so there's a much more complex infrastructure that people are now being forced to examine and deal with. And the end result is really that the people who are trying to analyze data are often the ones who pay the price. So they end up having to wait to get access to data. they tend to have to fight for resources, and just the ability to iterate and experiment is dramatically lower because of that. So that's where Snowflake started. And what we really wanted to do was take the best of a lot of the key technology trends that we saw out there, but bring them together in a new way that made it easier and faster and more flexible for people to do analytics on diverse data. So we started with saying that there's a lot of value in what data warehousing has traditionally provided. It's got a lot of enterprise capabilities. It's often something that you can get great performance out of once you've tuned it. We also said there's a lot of value in some of these big data solutions. They offer a lot of flexibility, schema flexibility, data flexibility, job flexibility, and they also are often very scalable. And so we wanted to incorporate that. And then we also wanted to take advantage of the fact that cloud technology is now the most elastic, the most agile infrastructure available, and actually in many cases is even more enterprise class than what people have in their own data centers, as Mike kind of gave you some of the information about. So we started out by saying we are going to take advantage of all of the different things that we just mentioned and build a brand new data warehouse built from scratch for the cloud. So it is a SQL data warehouse, but we didn't just take a traditional SQL engine. We didn't take something that's an open source project today and incorporate that. We actually knew that we needed to build a new architecture, and that required building a new database for SQL, but then extending that to support things that traditionally weren't something you could do with a SQL database. We designed it for the cloud from scratch. If you look at the common architectures out there today, pretty much all of them were actually originally designed for environments before there really was reliable cloud infrastructure. And so there were architectural choices that were made that made sense in an on-premise environment that actually don't necessarily take advantage of all the different capabilities you have in the cloud, and we wanted to do something that could take advantage of that. And then another really key point is that data warehousing and data platforms are traditionally thought of as very complex projects that are very intensive to deploy. There's a lot of overhead to manage them. You have to do a lot of care and feeding. And we wanted to actually take advantage of the fact that by building in a lot of this into software, we can take off the list of things that the customer needs to do. All of these things that are really not about analyzing data, they're really about maintaining infrastructure and optimizing infrastructure and monitoring infrastructure. We really wanted to build a data warehouse that really is a data warehouse for the analytics uses and for the reporting uses, and something that doesn't have a lot of overhead that makes it more difficult to deploy and use. So, the value proposition that we can fundamentally deliver is, one is to bring together a lot of different types of data and workloads into a single system, to make that path from when you receive data to when you're able to analyze it simple and easier and faster, and to do all that while significantly reducing the cost and complexity. And it really all starts with the architecture. So, when we started, we said, well, to be able to bring together all the data, traditional architectures actually don't do it that way. Traditional architectures force you to combine your compute and your data so that even if you have a large amount of data but you're only doing a small amount with it, you still have to buy, for example, a data warehouse appliance that is sized for the amount of data that you have. So we actually took a little bit of a contrarian point of view, and we said, well, let's go back to finding a way to bring together all the data in one location, and then be able to dynamically spin up compute resources as needed for what they're needed, and be able to do that through what we call virtual warehouses. So in our case, a virtual warehouse is an independent MPP compute cluster that can be dynamically created, destroyed, resized, up and down, to be able to be used to process analytics and report. So this architecture, because we've centralized data, it allows us to have multiple of these virtual warehouses so that we can actually scale up and scale down not only just the data stored, but also the compute capacity and even the number of workloads and users being accessed. To make this all work, as Brian kind of mentioned earlier, you want to separate that storage from what you're actually doing with the processing, but you also want to have that centralized metadata. And that's really what we designed into our architecture. We designed in this metadata and this cloud services layer to really keep track of the different data, how that data is accessed, to manage security, to optimize that access, and to do all that in a way that's scalable across a lot of different workloads that customers have. And then another key part was that we just saw how big the ecosystem was around SQL and SQL databases today, and we wanted to make sure that we could allow people to take advantage of that, let alone take advantage of the existing skills that their teams have. We've certainly seen that one of the big hurdles in a lot of data analytics projects is just the upfront challenge of getting your team to understand new technology and new ways of working with things and to build new tools and stacks of tools that fit that new technology. We wanted to make sure we could take advantage of existing technologies out there. And so because we are a SQL database, it's very natural for us to support standard interfaces like ODBC and JDBC so that the wide variety of tools that already know how to talk to a SQL database know how to talk to and work with Snowflake. One of the key things that we wanted to take advantage of leveraging that architecture was to make it easier to bring together data. So I mentioned earlier the fact that data has changed a lot, and there's a lot of different forms of data. And one of the big divides out there in the data world has been this notion of structured versus semi-structured or even unstructured data. In Snowflake, we wanted to make it possible to bring together structured and semi-structured data in a single system. Not only just that CSV type data, but also data that might be JSON or Avro or other semi-structured formats. We wanted to bring that together into a single system that didn't require a lot of pre-processing to make that possible, but also still give you great performance on that. Typically, the trade-off that you're forced to make in existing environments is if you want to get a system that can handle semi-structured data, it's not a SQL database. But if you want to get the performance of a SQL database, you have to change semi-structured data into a structured form. We actually designed a system that natively understands both of those and optimizes both of those, so you don't have to make those trade-offs anymore. Another part of bringing together all the different types of data is making it possible to scale that. So in a traditional environment, when you're working with on-prem data warehousing appliances, scaling of storage is actually a very painful consideration. You end up having to overbuy and over-provision because the cost of buying a new system, migrating data to it, migrating workloads to it is so high. Well, the cloud actually completely changes that equation. In the cloud, you have storage systems like Amazon's S3, which is the fundamental storage system that we leverage inside Snowflake, that are highly scalable. You only pay for what you use, and it's highly available as well. It's actually more available than the vast majority of data centers today are able to achieve. Mike mentioned those 11 nines of durability for that data, and also mentioned significant reliability in terms of just availability of access. So we take advantage of that, allowing you to scale up and scale down so that you can always, effectively you never run out of storage, and you never have to worry about capacity planning for storage. At the same time, we make it easy for you to scale up and scale down the horsepower that you're throwing when you want to process that data, at processing that data. So we've made it possible to scale up and scale down on the fly, in seconds to minutes, so that when you have a spike in workloads, you can certainly adapt to that without having to re-provision a system, without having to have another data mart created, without having to wait maybe days to redistribute data. And yet there's still one more dimension to elasticity and to scaling that we saw as a critical bottleneck for a lot of people. And that is that the traditional architectures all have different workloads sharing a common set of resources. And so effectively what that means is that the more workloads and the more users you add to a system, the slower it works for everyone. Certainly there's a little bit you can do with, say, workload management, queue management, but fundamentally that principle is true because all traditional architectures were designed for a fixed amount of resources. Well, we added in this new dimension where I can actually create independent compute clusters that can be scaled up and scaled down dynamically that all access the same data in a controlled, secure way. So now if I want to have loading happening at the same time as people are actually running their updated reports, at the same time as I have data scientists working in a sandbox, at the same time as marketing is running an update of its analytics, I can do that because of this architecture that allows me to do this without having performance impact from different people contending for the same resources. What this allows people to do is to really simplify that data pipeline, that second point that I made about our core value proposition. So not only is it about having fewer systems if you want to bring together structured and semi-structured data, that's actually been to date a very common reason that people do have multiple systems involved. We can actually take that data as is, put it into Snowflake without requiring transformation or fixed schemas to be defined. And then we can make it available to lots of different concurrent uses. So instead of the traditional approach, which is fork off new data marts, copy data, we keep all the data in one place. You don't have to copy data around. You don't have to wait for data to be migrated. But then we make it possible for different environments, different workloads, different users, different departments to all have independent access to that data. And then, that last point that I talked about earlier was just making this something that's much less complex, much less expensive. One of the key aspects of that is, turning this into a service. So a traditional data warehouse has a lot of overhead. You have to manage, of course, infrastructure if you're doing an on-prem data warehouse. You have to manage how data is stored, which could mean, distribution keys, sorting, things like that. You have to manage metadata often as well, and you typically end up spending a fair amount of time manually optimizing queries. Maybe you create indexes to optimize queries, maybe you create hints, all of these different things. We really saw that as being a big bottleneck to getting more people access to more data and more analytics faster. And so what we did was we built into software all of these different aspects so that the user of data doesn't need to think about them. So in Snowflake, because we're a cloud service, there is no infrastructure management. We take advantage of the world-class capabilities that Amazon has for managing, deploying, monitoring infrastructure. For data storage, we take care of that automatically and dynamically. Snowflake is constantly in software watching how data is being used and distributing that data in the most performance efficient way. We also take care of automatically updating metadata and managing that, so that you can always benefit from optimized performance that understands your data and your queries. And we actually also do a lot of optimization of queries themselves so that you don't have to think about workload management. You don't have to think about queue management. We've provided options to make that very easy to do without having to get into all of those complexities. So where do people typically get started with a solution like Snowflake? There's really kind of three common scenarios. One is that they have diverse data, typically semi-structured and semi-structured data that they need to bring together in a single system, and they want to do that more efficiently and more performantly. Another is that they have a lot of different data marts, and they're trying to figure out how to bring that back together because just the cost of having those different data marts, of managing them, of copying and federating data, and securing that is all becoming too much for them to handle. And then the last thing is, we talk to a lot of companies who are today building SaaS applications that are data-driven, whether they're for internal use or for their customers to use. And these companies typically don't think of themselves as wanting to specialize in building a back-end database for processing that data. And so Snowflake is a natural fit for them. It scales easily based on the demands that they have. It doesn't require additional operational overhead and management. And it's very flexible, can be deployed and paid for only for what you use. So just to go to a specific example, and this is that customer that Brian mentioned earlier, DoubleDown. They have a lot of event data from their online games. So they have data about everything from what a game player did at this point to what was the state of the game, at what point were they offered an opportunity to purchase something, at what point did they exit the game. All of this is stored in JSON format. And what they've been doing before was they've been putting that into a NoSQL database, using that to process it into a form that they could then stage for loading into their data warehouse so that their analysts could get access to that data. But the challenges that they had, this is a very fragile pipeline. They had to do a lot of work to kind of construct that set of transformations in that NoSQL system and to maintain that system. It took a long time to actually get data to analysts. Frequently, especially when errors happened, it could take a full day for an analyst to see new data. And on top of that, even though that NoSQL database was an open source product, it actually was still costing them a lot of money in just the cost of deploying, managing, and monitoring that. So what they did was they replaced that with Snowflake. And now what they do is they use Amazon's Kinesis product, which allows them to take that streaming event data, put it into that pipeline, and then put that into Snowflake along with their structured data about player profiles and offers and things like that. And they can do transformations directly within Snowflake now because Snowflake allows them to load that data as is and transform it there. And at the same time, Snowflake can also both support things that need to go into their existing EDW for the existing tools and processes they have there, but it also supports direct access by analysts. So analysts can get interactive performance on data by directly accessing and using Snowflake as the back-end engine for that. So in this case, a lot of the fragility of their data pipeline was limited. They saw the error rate go down dramatically because there's just fewer moving parts that they had to manage. They were able to get data to their analysts dramatically faster. You can see the performance comparison here in that before that pipeline, at best was taking about 11 hours to get data through. At worst was about 24 hours. In the Snowflake case, it now takes 15 minutes. And even though before they had been using an open source product, which one always assumes is going to be cheaper, in this case they actually were able to reduce their cost by 50% because the operational overhead of managing that previous environment was so high. And then one other benefit that's really important is they were actually able to keep more data and analyze more data. So before, they had to look at just aggregates of data that were on a much less granular basis. Now they can actually go down to up to the minute data and actually access that and get better insights from that. One other example is an enterprise customer that we've been working with. They had their raw data currently being put into a data mart, and they were putting summaries in that data mart, and then running different types of analytics, machine learning, and reporting off of that. They were really challenged because that system was just creaking from being overloaded. They had to deny people access to data, and they had to deny new projects because it was such a big expense to step that up to a bigger system. But by putting Snowflake there in place of that data mart, they were able to not only give the existing workloads better performance, but because of that architecture that Snowflake has that allows you to spin up additional compute clusters, they were able to add new workloads without a big 5 or 6 figure cost just to get started. So for them, that improved the experience for the users of those reports in that they were getting their reports calculated 90% faster. They weren't seeing slowdowns when lots of people were using the system, and they could try a lot of new projects that they couldn't have before. So that was a very brief run through of Snowflake. There's certainly a lot more information that we have available on our website. You can take a look at and learn a little bit more about Snowflake. If you're interested in seeing a demo, we actually run a regular webinar demo program, and we'd love to have you join us for the next one. The next one is coming up shortly in just about 2 weeks. So feel free to go to our website. We will send you a link when we follow up to give you the URL to where you can go to register for that demo. So that wraps up my portion. I know we're just about to the top of the hour. I will turn it back to Keith in case there's any wrap-up questions he wants to quickly ask before we...
Sure. Thank you, John, and thank you to all of our presenters today. This does lead us to the question and answer session. We'll just take a few moments to take some of the questions that have come in. As a reminder, you can submit other questions that you have through the chat window of the lower window of your ReadyTalk platform. John, first question is for you. Scaling up and scaling down with Snowflake. Is the cost all done through Snowflake, or would a customer have to have a separate agreement with AWS?
Yeah, so that's one of the aspects of as a service that we built in that we actually completely incorporate the Amazon infrastructure in the way that we build our software. And so we actually do have customers who don't have an Amazon Web Services account, but by using Snowflake, they actually benefit from all of the great things that Amazon Web Services provides. Certainly, customers who are already using Amazon Web Services, who have data in S3, it's very easy to use that data in Snowflake as well. But even if you don't, Snowflake bundles the cost of using Snowflake, in a bill from Snowflake, and so you don't even need to worry about the underlying costs. It's all taken care of and managed and calculated and monitored by Snowflake.
Great, thanks. And one more question while we have some time. John, question for you. Data warehousing and BI are still weeks and months of efforts before any analyst can make use of data insights. How can we simplify that time and effort to custom solutions?
Yeah, so it's definitely a good point that no BI and analytics project is the same. They all have their own uniqueness. And there are some parts of that still do require some time spent planning. For example, how are you going to do data modeling? What is the data that you want to get? How are you going to, for example, do master data management if you're bringing together a lot of different data? How are you going to ensure data quality? So there's certainly aspects of this that are outside the scope of what Snowflake provides with its solution. But what we've really focused on is, once you've gotten those questions answered, how do we make it very easy to actually implement that? And so, there's aspects ranging from the fact that, because the infrastructure is all taken care of by Snowflake, you don't spend time procuring hardware. You don't spend time waiting for the data center team to get that up and running. You don't spend time installing software. It's a very simple, fast process for us to set up a new customer with an account in Snowflake. Then also even just loading the data. So because you don't have to do a lot of transformations to convert semi-structured data to structured data, that dramatically simplifies a lot of the work that otherwise would have been required to pre-process data to make it possible to get it into a warehouse. And then because we support standard SQL and have integrations with the key major vendors of tools for visualization, BI, and analytics, you don't have to spend time figuring out what works with your particular tool or changing your tool. So we really are trying to make it possible to have you focus on the things that are your value are your key value, understanding your data and what you want to do with it, and take care of all the other things that basically were bottlenecks that made it hard for you to actually execute that plan you'd put in place.
Great, thanks, John. Just one final question. Which database is Snowflake based on?
Oh, yeah, it's a good question that we do get a lot. So we actually decided that we needed to build a new database from scratch. And so we have a team of very experienced people from vendors, including Oracle, Teradata, Cloudera, Google, other vendors like that who are really experts in building systems like this. And so we didn't start with some open source project or some commercial core database or NoSQL system. We actually built that database from scratch ourselves to be able to make it optimized for the cloud and for what we saw people trying to do.
Well, great. This is all the time we have left for today. As mentioned, if we haven't addressed your question directly, we'll be following up with you individually by week's end. Again, each presenter's contact details are available on your screen, and Snowflake will be following up with you with a link to today's recording. Thank you again to our presenters from Forrester Research, Amazon Web Services, and Snowflake Computing. Thank you for joining us. Have a great day.